first thing is I'm really excited to see you here. Like, I'm a Presto groupie. I don't know if you can say that, but I'm a real Presto fan. And having you here is really exciting. I'll talk about Varada. I'll talk about what we do and how we integrate to Presto and use Presto to enable what we do. So let's go. So Varada is a new entrant to the, can you hear me well? Great. Varada is a new entrant to the big data analytics infrastructure market. We are currently in a beta program with few enterprise customers, and we'll launch the availability of some of the things I'll describe here later on. Our mission is to enable better, faster, easier analytics on cloud data lakes. And I'll talk about that in a bit. There is a shift that's happening in how data applications are built and what they need. And you probably know because you're here, but they need more data. They need larger volumes, they need more dimensions, the decision window is larger, they need more complex data, they need more data sources. And once you're at scale, that kind of data is typically, or a large part of it, comes to a data lake that stores that because it solves the problem of how do I store all that data and decouples that from how do I analyze that. That is also meaning that the mode of operation of a data lake, the use cases it has to serve are also shifting from an ad hoc query to an interactive dashboard, from batch to real-time decision system. And the first question, obviously, we're at Presto conference. So is it a task for Presto? And a few good things going on for Presto. Presto can handle any volume of data, huge volumes. Presto can handle complex workloads, diverse queries. Presto can handle high concurrency very well. It can scale to thousands of nodes. But one thing area where it gets interesting, when you start to work, is when you want to have predictable interactivity. When you have a data application, that business dashboard, that expects an SLA, and you want to maintain that kind of an SLA, whether it's a sub-second, sub-2 seconds, sub-10 seconds, doesn't matter what the SLA is. Once you're that area, with Presto, and by the way, when I say Presto on S3, I mean Presto on org files or Parquet files on S3, Presto on a data lake. That's where it becomes interesting. Now, there is previous attempt that's built in Facebook by those guys and is used in a few other companies, called Presto Raptor. Presto Raptor, the basic idea, how do we get to lower latency for a dashboard? And let's store the data on SSDs, which are local to the Presto workers. So the data is copied to SSDs. It's a cluster, so it's sharded, it's partitioned across many nodes by some kind of a shard key or partition key. And the data is stored in a columnar fashion. So it's sorted in some dimension. And so when you have a workload and you optimize for that, and your joins are collocated by the partition key and your queries hit by the dimensions you choose, then you can serve those from SSDs locally. Now, the problem with that approach is that's a heavy customization work for a specific workload. It requires data modeling, sorting, distribution, understanding how your queries fit, how they perform, limiting the queries, limiting the data set, optimizing the workload, the concurrency, the bottlenecks, building an ETL pipeline to transform the data to be relevant to that, maintaining the copy, maintaining consistency, freshness, which is basically a hard thing to do. It's heavy lifting, which means long implementation cycles, both for initial deployment and to handle a change in demands. And sometimes also means compromising on what you can serve, whether it's very specific workload that's supported or compromising because you have some kind of an SLA to match. So, but still, what's Presto Raptor? So what would you need? What can you make to make that problem easier? What are the areas that need significantly to be reduced? It's data modeling, Let's not think about sorting or partitioning. It's copy management. Let's not think less about how we manage those copies. Because S3 or Hadoop or any data lake by itself will not get the latency. So the data is always somewhere faster. And how we can avoid thinking about bottlenecks of workload, because workload is unpredictable by nature. You don't know what people are going to use. You kind of know, but then they do something else. So let's talk about Varada. There's two ways to think about Varada. There's Varada, the product. It's an analytics platform. It sits between data lake and a data application, and enables that predictable interactivity. But in the Varada product, there is Presto. And in this Presto, there is the Varada connector. Because on the technical layer, Varada is mostly implemented within a Presto connector. And I'll talk about how they achieve that and how they use Presto to enable that value. First of those things is architecture. So that's basic Presto architecture. There's a coordinated node, there are worker nodes, and there are local attached SSDs, because that's a faster layer to keep the data in. But the first transformation we do is make that into a shared everything architecture. So that's the same physical nodes that have local SSDs attached, but in a shared everything environment, which means that every node, every worker node, accesses all the data with local latency. Now, to achieve that, we use a combination of few technologies. There is NVMe SSDs. That's a storage protocol for SSDs. NVMe over Fabrics. That's a networking protocol. And various ways to keep everything uniform. Memory, compute, storage, queries, to not hit a bottleneck. But once you do that, and that thing scales to a few thousand of cores, you no longer need to think about data skew, because everything is local. You no longer think about collocating joins, because everything is collocated. You no longer think about data locality-induced bottlenecks, a node that's stuck, because, again, all the data is local. On top of that physical layer, you need to put some data in. And so the approach we chose here, and that's something that was also done in Presto in various environments, is something that's in database speak, a materialized view. So instead of building an ETL pipeline, you define with SQL what's the data set that's relevant for the application. I want the last 3 months of that table. I want that table and that table, a couple of views. I want to join those. And once you have that definition, which is executed as a Presto query by itself, as a Presto on Hive S3 query by itself, on Oracle per K files, then you put that in. But in the SSDs, it's not just a cache, because now the next problem to solve is data modeling. How do we enable fast performance without choosing the dimension? And the way we approach that is by indexing. Indexing across everything, indexing across all dimensions of the data. And I'll dive a bit into indexing. That's a particular area that I'll dive into more in a minute. But to understand the value, if the index can perform as fast as sorted data or close enough, then you no longer need to think about how do you choose the dimensions for your dashboards, and you no longer have to limit the dimensions that you expose. But there's a copy. So by introducing copy, we also introduce copy management, which is a problem by itself. So the only way to solve that is making those copies as transparent as possible, which means real-time synchronization. The copy is defined by SQL, last 3 months of that table. That SQL enables to know what's relevant and what's not. So we track the changes. We track the changes on the data lake, and we updated that view, that materialized view. If there is a file added, it's added to the view. If it's removed, it's removed. If the schema changes, and we get new dimensions, then we build new indexes for those. So go back to index. So we've got that physical layer, which is elastic and shared everything. And you've got that copy management. And we identified there are few ingredients you need to get to be able to index 100 terabytes across all dimensions. And those are random I/O, small blocks, and low latency, things you can get from an SSD if you use it right. And a high bandwidth. We're still dealing with huge quantities of data and large volumes. So you need that in a cluster. To get high bandwidth with random I/O, you need shared everything. The way the index works is simple. Take the data, break it into very small parts. How small? From half a kilobyte to 8 kilobytes each. We call those nanoblocks, but basically the small blocks of SSDs, pages. Each one is a columnar storage unit, part of a column, which has its own columnar compression, its own encoding, that is somewhere across that large SSD space. Then take a bunch of those, and we build an index. How much? Many? Up to 100,000 rows of a column. The actual number is adaptive. And we build an index for some part of that column, which only looks at the data of that part. Looks at its type, looks at its distribution, its statistical properties, at its cardinality, and chooses the index that's best for that. If you got a temperature in a small range, that's an index for a small range of numbers. If you've got a high cardinality user ID, then that's an index for high cardinality values. If you have strings, then strings index for string matching. And once you have that, and the indexes are also stored in small blocks across the SSD space, then you basically do random walk. So you've got a query. You look for high temperatures. And you go and ask all the indexes, well, many of those, on the temperature column. Some of them will tell, don't even bother looking further. There are no high temperatures here. Some of them will point to those rows have high temperatures. And basically, every query finds an index. Whether it's a filter or a join, which is also an application of an index, you can use that to improve the query. And specifically joins, Roman will speak, Zaida will speak a bit later about how joins can be implemented better in Presto with dynamic filtering. Dynamic filtering is something that helps not only Varada connector, helps other connectors as well. And Roman will talk about how it works. And we'll also show some performance numbers on what it means to use that within the Varada index. Altogether, that's an analytics platform. So you've got a Presto. The Presto has all its regular connectors. His data application might need MySQL or Postgres or other data sources, and might need the data lake directly. And then on top of that, there is an automatic synchronization of data to a materialized view, and an index within the materialized view to serve queries with consistent interactive performance. And connect to that data applications that talk basically SQL. And fortunately today, there is almost nothing that doesn't know Presto, which is not true just a couple of years ago, but is true today. Because it doesn't matter which BI tool or thingy that talks SQL you pick, probably it knows how to do Presto, and probably it learned to do that in the last 6 to 12 months. Right? Ori told me no questions, but I'll be there here on the break and at the panel, I think.
Yes, exactly.
So,
thank you very much, David.